Okay, folks, let's go ahead and get started. Let's pick up where we left off with yesterday. We were talking about motion, and it was necessary for me to go over all this information with you regarding uh, how we describe motion in physics, which is the study of mechanics. So, mechanics is essentially the study of any moving object. And so we need to learn about that. We need to be aware of that because remember, with gas particles, and actually with all particles, whether they are in the gaseous state, in the solid state, in the liquid state, they're in constant motion. And so if we are able to describe that motion, we can then start talking about how that motion affects the properties that we will be able to study, to examine of a gas, of a liquid, and of a solid. Okay? And so that's why we have to invest this time at the front end of this discussion to talk about physics. And so this is a little bit more physics than I think many of you may have had before, but many of you will see this again because most of you will end up going on to physics and studying that next year or the following year. But it's essential that we know this because if we're going to describe the pressure that a gas exerts, the pressure that a gas exerts is directly related to how it moves. Okay? And if we can understand that, we can then trace then the pressure and what causes pressure. Okay. All right, so with that said, then let's take a look at where we left off with yesterday. Okay, and then I'm just going to quickly review this and then we will move on. And hopefully, you were able to take advantage of those notes that I posted for you. And I think I will try to do that from now on, where I will try to post for you the lecture notes, and that way, then you will have that to review as well. Okay, but this is on your lecture notes yesterday, and you were able to see that. We were able to define then the energy of a particular molecule. This, remember, refers to kinetic energy, which is the energy involved in any moving object. And so the kinetic energy then is defined then as an object, and all objects have mass. And so mass is an integral part of this kinetic energy calculation. And the object has to be moving. So V here is the velocity. We were able to describe velocity then as the speed at which an object moves and the direction in which it moves in. Okay, and so we need to know about kinetic energy, and this is going to be important when we get to the discussion of temperature and kinetic energy. This is going to come back again. Okay, but we do need to make sure we understand then that as these gas particles move around, they have a certain amount of energy associated with them. Okay, now the masses of these gas particles are going to be very, very small, but their speed will be extremely fast. The velocity will be extremely high. And because of that, they carry with them a lot of kinetic energy as well. This kinetic energy is going to be directly related to the temperature at which the gas is under. So we'll talk about that hopefully today. If not, we'll talk about it tomorrow. But we'll get back to this discussion hopefully, like I said, tomorrow. Okay. All right. So as these gas particles move around, okay, they interact. So the first bullet point here describes then the energy at which the gas particles move at, and that will be important in the pressure that they exert. Okay. But they also exert this pressure because they are interacting. They are bumping into, they're moving around, they are colliding with all of the particles around them. They are colliding with the walls of a room or the walls of a container. So they are pushing and pulling. Now, do you understand this? When we talk about ideal gases, and we'll talk about this a little bit more when we get to chapter 14, when we talk about ideal gases, we are assuming then, the assumption we make then is that even though they are colliding with one another, they are not interacting. They are not pulling or pushing each other in such a manner that will cause them to stick together. So I just want to throw that out there for right now because when we get to that discussion in chapter 14, we talk about ideal gases. Even though we know that these gas particles are moving around, they are bumping into everything, they are pushing everything out of their way, the types of interactions that would require to get them to stick together is very, very small. Okay, so just file that away in the back of your mind, and we'll get back to that in the next chapter. Okay, but as these particles move around, we can describe this pushing and this pulling interaction that they have with one another using Newton's second law of motion here. And basically, Newton's second law of motion relates for us the amount of force that a particle, a gas particle, or any object gives will be directly correlated to the acceleration that it will have. So the force that it feels will be directly to the correlated to the acceleration that it has, and also the mass as well. Okay. All right. So with that said, then A in Newton's second law then stands for acceleration. We said that acceleration is a change in velocity over time. This acceleration then represents either an object speeding up, slowing down, or changing direction, essentially the changing in motion. So acceleration is directly related to an object as it changes the way it moves, and an object changes its motion as a result of a force acting upon it. Okay, so make sure you keep that in mind. Right, finally, then, we're kind of going through here then to describe velocity, since velocity is used to describe then acceleration and kinetic energy. We describe velocity then as the rate at which an object changes its position. That is how fast it moves from one position to another. Okay, so basically we're saying then it's how fast an object moves. And so that's where we left off with yesterday, and that's going to be quite a bit of information that you'll need to know as we move forward. But like I said, I'm going to use some of these equations here to help you with kind of understanding how pressures and forces, how forces lead to pressure, and how pressure then corresponds to how gases behave when it comes to the temperature of the gas and also the volume that comes that the gas occupies, and that we'll discuss when we get to chapter 14. Okay. All right, so let's go ahead then and let's continue on with this discussion of what forces are. Okay. All right, so a real quick, simple way that we can describe what a force is, because we need to know what a force is, because like I said, Newton's second law, we talked about Newton's second law, and Newton's second law refers to force. Okay. So let's imagine that we have an object. Let's imagine we have our ball. The ball here obviously has a mass. Okay, so we'll label that with the letter M, which means that it has a certain mass. Whatever that mass is, we can weigh out, we can drop it on a count. Okay? Now, initially, this ball is not moving. Okay? This ball is not moving, so we can say then that the velocity of this ball is going to be 0 meters per second. That is, it is not moving, so we represent that velocity. That means its speed as 0. So if the object is not moving, its speed is 0. I think that makes sense. How then can we get this ball to move? That is, how then can we get this ball to have a velocity? How can we get it to move in a certain direction? Let's just say, how do we get this ball to move towards the right, for example? Let's say then we want it to start moving. Okay, so it has, and now then it will have a velocity that is not equal to 0 because it is moving now. Remember, velocity equal to 0 means it is stopping. Okay, velocity not equal to 0, it means that it is moving. That means that it has a speed. Okay, so how do we get this ball to move? Okay, and so if you notice here then, if we start out at a velocity of 0 and we end up at a velocity that is not 0, we are changing the way the object moves, and therefore then we have an acceleration. This object, this ball, then it's going to undergo an acceleration if we get it to move, if we get it to start moving. Okay, so it will accelerate. Okay, and how do we get it to accelerate? Well, let's consider this here. Don't worry about that acceleration right now. We'll come back to that. How do we get this ball to start moving? Well, there's one thing we can do. We can go in and we can push the ball. Let's imagine we go in and we push the ball. If we push the ball towards the right, then this ball that was initially not moving will then start moving towards the right. So imagine go in and you kick the ball. If you kick the ball hard, it doesn't matter how hard you kick the ball. If it's not moving initially, if you touch the ball, if you push it towards your right, then it will start moving towards the right. So this will be then a push. So you're applying a force here. So if you are pushing on the ball, you're applying a force. Okay, so you're pushing it in and it starts to move and it starts to accelerate. It starts to experience an acceleration. Okay, so that's one way. Okay, let's imagine then you come in and you pull the ball towards the right. Okay, so instead of pushing the ball on the left side of the ball, you come on to the right side of the ball and you pull the ball towards the right. So you're going to pull the ball. As soon as you pull that ball, it will start moving. It will change the way it moves, undergo an acceleration. So therefore, then this push or this pull here will lead to a change in this in its speed, and thus cause the ball to accelerate. Okay, and so we can define then force. Okay, we can define force then as a push or a pull. Okay, force then, and let's go and do this. Force then is going to be a push or a pull, okay, acting on an object. Okay, so force then in the end. So when we talk about force then, a force then is either a push or a pull that causes an object to change its motion. That's the simplest way then that we can define what force is. Okay, so force then is either a push or a pull on an object in order to get that particular object to change the way it moves. Okay? All right. So the object, you apply force to an object, the object will change the way it moves, or, okay, once that object starts to move, okay, then it can go ahead and exert a pressure. Okay, so a force is applied to an object, you will also exert a pressure on that object as well. So just imagine with the ball, if you push it on the ball, that force is there, but there's a pressure that you apply on that ball as well. And same thing holds true for the pull. Okay, so let's go ahead then, let's examine this relationship between force here and pressure. Okay, let's go ahead and take a look at that. Okay, so here's our ball again of mass m. Let's go ahead and take a look at this again. So this is our ball of mass m. So there it is. Okay, okay. And let's say right now it's already in motion. Okay, so we set it in motion. Okay, so we've kicked it, or so that means then the velocity is not equal to 0. Okay, that means then we've already pushed it or we pulled it, and it's already moving towards the right. Okay, so now this ball is moving. Okay, it's moving. And let's say it moves towards this wall over here. Okay, so there's a wall here. Okay, there's a wall here, and it starts to move, okay, and it pushes up against that wall. So what we're going to do here is this ball then is going to push up against that wall. Okay, and once it pushes up against this wall, let's just imagine the moment before it bounces, its velocity then becomes 0. It stops, which means then as it pushes in here, it changes the way it moves. It changes the way it moves because the wall stops it. So it is experiencing a force. Now, without getting into too much of the physics here, what's causing that ball to change the way it moves? Well, the wall here is pushing back out on that ball. As the ball comes in and hits the wall pushes back on it, and it's the force of the wall pushing on the ball here that causes the ball to come to a stop. Okay? And so if the ball starts out with a velocity that is not equal to 0, that means it's moving. And if it changes to a velocity that is 0, that means it comes to a stop. The ball, again, undergoes an acceleration. This time, though, the force that's causing it to accelerate. And I think the problem that many of you will have here is that you associate the term acceleration with speeding up, but that's not the case. In physics, acceleration refers to just a change in the way an object moves. That means speeding up or slowing down. So with that said, then the ball comes in, it applies a force. So the ball will push. The ball does apply a force. So we'll call this the force of the ball, okay, on the wall here, okay. But that's the force of the wall, ball on the wall. Okay. But what causes this acceleration here is the force of the wall, not the ball here. The force of the ball. Of the wall pushing back out that way. Okay? So that's what causes the ball to come to a stop. But we're not going to, and that's essentially what we have here with Newton. What Newton describes that in his third law of motion as well. But that's not what we're concerned about here. We want to talk about what happens when the ball here pushes in on the wall. Okay, so we want to talk about that. We want to examine that really quickly, because what happens here is that the ball here now at this point applies a force onto the wall. Now, why doesn't the wall move? That's another matter. Let's hold off on that question for physics. Or if you are interested in it, stop by after school today, 1:30 to 2:30, and we'll talk about why the wall doesn't move. Because we should expect the wall to move. Obviously, it should move because the ball here is applying a force. The ball is applying a force to the wall. But why doesn't the wall move? Come by and see me. Okay? Or if you're not that curious yet, then you can wait a whole year for physics. Okay? But this is the force. This is the force that the ball applies on the wall. So if the wall doesn't move, does the ball affect the wall in some other way? And the answer is yes. Okay. What the ball does is it applies a pressure. Okay? What the ball does is it applies a pressure at this point right here. As it pushes in, it applies a pressure. As it pushes in to the wall, it applies the pressure. It's very similar to what if you can imagine this, if you go in and you push against the chest of or push in on the shoulder of your friend. your friend's going to feel that pressure right there on his or her shoulder because of the push that you are exerting on your friend. Okay, and so here I want to point this out to you because I want you to see then that there is a relationship between the force applied by an object and the pressure that it exerts. Okay, so there is a relationship, and we'll write it this way: is there has to be a relationship between the pressure that the force that an object exerts, so this is going to be the force, and the pressure that it exerts. Okay, so this symbol here is a proportionality symbol. You see that in math. So there has to be a relationship. Basically, it's expressing a relationship between these two quantities here. And so the question is, can we make use of that relationship? Okay, and that is, can we make use of that relationship to explain then, okay, why pressures are different for different objects? Okay, and so we want to be able to explain that. Okay, and furthermore then, okay, how do we determine then the pressure exerted by that particular object? Okay, so we know then, first of all, that pressures are going to be different. Different objects will be exerting different pressures. But can we take advantage of that relationship between force and pressure to be able to determine then the pressure exerted by an object? So let's go ahead and take a look at that really quick. Okay? So let me give you an example here. Okay, so let's consider this. Okay? If I step on your foot, just let's imagine I come by and I step on your foot. I'm pushing down. So as I push down, I'm exerting a force. Okay, so make sure you remember this. So I am pushing down. So this is a push that I'm exerting on your foot. So I'm pushing down, so that means that I'm exerting a force on your foot. Okay, so as I push down, I'm exerting a force on your foot, and you can feel that force because it's going to be the pressure that I exert on your foot. Okay, so that's going to be the force right there. Okay, all right. So with that said, we see then that there is again the relationship between force, okay, and pressure. Okay, so as I push down on you, I exert a force, but you feel that force in the terms of pressure. Now, is this always going to be the same? Is force the only factor that determines the pressure? And I'll try to finish up here real quick with you, for you folks. Is force the only factor that affects pressure? Okay. Well, let's consider this here. Okay. Let's say then that we took an elephant. Okay. So the elephant's going to push down on your foot. That means the elephant's going to step on your foot. So the elephant will push down on your foot. So there's a push. So therefore, the elephant exerts a force on your foot as well. But let me ask you this. Is the pressure that you feel, is the pressure that you feel the same as the pressure here? That is the pressure here when the elephant steps on your foot equal to the pressure that you feel when I step on your foot? Obviously not. Okay, so the pressure of the elephant, and I just want to write this here for you, the pressure that the elephant exerts is going to be much greater than the pressure that Mr. N exerts here. Okay, so this is me. This is the pressure that I exert when I step on your foot. But we know then if the elephant steps on your foot, it's going to hurt a whole lot more. And so therefore, as we take a look at this here, what's the difference here? Okay, well, the difference then is that the force in which the elephant steps on your foot with is going to be greater than the pressure. So there is still a relationship here between pressure and force. Okay, so therefore then, as the reason why the pressure increases here, the reason why the elephant exerts a greater pressure on you is because the elephant is stepping down on your foot with a greater force. Okay, if you want to think about it this way, my force that I step on your foot with is going to be much less than the force of the elephant. Okay. All right. So with that said, then I don't like that. I don't want it to be upstaged by this elephant. So what I do then is I go and I put on, let's say, a pair of high heels. Okay. So I step on your foot with a pair of high heels. So this is still Mr. N. So this is still Mr. N. Okay, wearing a pair of high heels. So this is going to be Mr. N this time wearing a pair of high heels. Okay. So yeah, that's my leg right there, folks. Okay, so this is Mr. N again, wearing high heels this time. Okay, so my question to you then is, do I push down on your foot? And the answer is yes. So I also exert a push. I push down on your foot. Okay, and thus I exert a force on your foot. Okay, my force that I exert here when I wear high heels is not different from the force that I exert here. I still weigh the same. I will step on your foot with the same amount of force. But my question to you is this, okay? Is the pressure that you feel, okay, this time, that the pressure that you feel this time, and that is the pressure of Mr. N in heels, and let's go ahead and write this down, okay? The pressure of Mr. N in heels versus the pressure of Mr. N in a shoe, okay? Which one is greater? Obviously the pressure. You will feel, it will hurt a whole lot more when I step on your foot with when I have high heels on than when I have my shoes on. And so the question here then is, if the force is the same and the push is the same, what's going on here? What accounts for the greater pressure here that you would feel if I step on your foot with heels, as opposed to when I step on your foot with a shoe? Okay, so let me go and write this here. Write this down here, because I want you to answer this. Okay, with the question, what I want you to write down now on your paper, okay, is why. Explain why then the pressure. Why is the pressure greater in this instance here when I step on your foot with a pair of high heels, as opposed to when I step on your foot with a pair of shoes? Okay, so answer that question. Why is the pressure here greater? Force is the same here. Okay, the force is the same here. Okay, the push is the same. But why then is the pressure greater? Okay, so write that down on your paper, okay, and then make sure you submit that. I will start with this. I will answer that question for you tomorrow. Okay, so hang on to your answer. Okay, and I know that you may or may not have the right answer, but that's okay. I want you to be able to think about this, and then that way, then when we talk about it tomorrow, you'll hopefully have a better idea of what's going on. Okay, so the question then again that I want you to finish out with, I want you to write it on your paper. Why will the pressure in heels be greater than the pressure when I wear shoes? Is there another factor? That's the question you want to be able to examine. Is there another factor that affects that determines pressure apart from the force here? Okay. All right. So please make sure you answer that question. Okay. Make sure you answer that question, and we'll get back to this question tomorrow. Okay. All right, folks. Have a good day, and I will see you tomorrow.